Hello, I'm Kirsch Mackey, and I'm going to show you how to create an arbitrary footprint, especially for an unconventional circuit component. What you're going to learn in this video is how to use OrCAD PCB Editor Lite to create any arbitrary footprint that you so desire. You're also going to learn how to use Padstack Editor to create any Padstack. And you're going to learn how to bring those two together and add silkscreen layers, solder mask layers, and save the footprint in PCB Editor. Alright, so let's get started. The device of choice is the GS66504B. I'm going to go straight to the datasheet. And the first step in making an arbitrary footprint is to definitely look at the datasheet. I'm sure you already do this, but just always keep this in mind and to read it carefully. So, two things that we'll need to know. The package outline for the device, the pin numbering 1, 2, 3, and if we scroll all the way down, there's more information. This is the package dimensions information and the recommended PCB footprint. Usually I go with the recommended PCB footprint from the manufacturer because they've tested these devices and they know best how to use them, and they manufacture and engineer them. So I trust their judgment. Sometimes the recommended PCB footprint is incorrect. That happens rarely, but just keep that in mind. Watch out for that. All right, that's enough about the datasheet and the idiosyncrasies. We're just going to go straight into it. So what you do is click on the Start menu, go to Cadence, Release 17.2, and then click on PCB Editor Lite. It'll open up. Alright, yes, we want to enter Lite mode. Now what I'm going to do is use the data from the information from the data sheet, and I'm going to first draw the outline of the package. Then once I've drawn the outline of the package, I'm going to create the pins or pad stacks. Then once I've created the pins and pad stacks, I'm going to go back to the package outline that I drew in PCB Editor, import the pins into the package symbol, add some reference designators, some silkscreen, and then save it, and then it will be done. Alright. So, what I first look at is the outside dimensions of the package. The width and the height are A and B dimensions. So, and we are in millimeters. So I need to set up my environment to make sure that I'm in the appropriate setup. So let's go to File and then New in PCB Editor, and then choose Package Symbol, not Package Symbol Wizard, but just Package Symbol. Now I'm going to click Browse, and then I'm going to get to these eventually, but let's just go to Complex Footprints, and I'll create a new folder called Gallium Nitride. Actually, let's delete that. GS66504B. And actually, I'll Control A. Or B. Alright. Yeah, I was supposed to create a new folder. Alright, so now the file name within that folder will be GS66504B and it is a symbol drawing type. So click Open, and that is the name of the drawing, the packet symbol, then click OK. Next, what we're going to do is check to see if our setup is good. So click on the Setup tab, then click on Design Parameters. Click on the Design tab and make sure that your units are in mils. Alright, so actually that's my mistake. Make sure they're in millimeters. Now why do I choose millimeters? That's because I checked the data sheet and the units are in millimeters, so that's why. And now the units are also in inches, but I prefer the millimeters just because that's the primary units that they use. If they use inches as their primary measurement, then I would go with inches. Alright, so back in the PCB Editor, choose millimeter and then click Apply. Next we'll go with Display tab and then click on Setup Grids. Now the grid spacing is set to 2.54 in the non-etch spacing. So what do you put the spacing as when you're working with the package? Usually I like to go with the precision of the datasheet. So go back to the datasheet, check that the A dimension is 5.01 millimeters. Now there is greater precision, like to 1,000th of a millimeter, but I don't think that much that high precision is necessary. I'm just going to go with the 100th of a millimeter. So I'm going to go back to PCB Editor and choose the spacing in the X non-etch spacing to be 0.01 millimeters, and the Y the same, 0.01 millimeters. I'm also going to choose all etch spacing to be 0.01 millimeters, and in the Y 0.01 millimeters. Alright, click OK. You can turn the grids on if that's what you prefer. I like the grids to be off, so I just uncheck it, and then click Apply, and then click OK. Alright, so scroll down to zoom out. Your origin should show up. Now if you can't find your origin, this can be a common problem. If you can't find your origin, go back to Setup, click on Design Parameters, and just choose Design. Now notice there's a Move Origin option in the X and the Y. Going down to the left here, our origin is actually down in the 0, 0 coordinate. So I'm going to change that to, if you look at my mouse cursor, and if you look at the coordinates down here, you'll see that it's around 240 can be the center. So let's choose 240 in the X move margin. And in the Y move margin field, click on there and also put that as 240. And hit Tab, then click Apply, then click OK. Alright, so now we have the origin in the center. Okay, now that is just setting up the environment. Alright, so like I said earlier, I'm going to create the package outline. Finally, I can get started with that. So the X dimension, the width is A. Go to PCB Editor and choose Add Line. Now, we are in Add Line mode right now, and you want the line to be of a certain active class and subclass. Choose Package Geometry, Assembly Bottom, and then choose the line lock to be 90. Now, where am I doing all this is in the Options tab. If you don't have the Options tab available, it should be maybe hidden on the right side here, and then you just click on it and it shows up. I have it pinned in my setup, so you just want to make sure the Options tab is available on the right here. Okay, so line lock is set to 90 degrees, and the line width, I'm going to change that to 0.12 millimeters. By default, it's set to 0.0. It's just 0 millimeters, so it's 0 line width. But those can be pretty annoying once you get to creating photo plots and Gerber files for your devices. So I just changed it to line width 0.12, and then now I'm ready to place a line. Now I can click and then place a line, just arbitrarily. It'll continue doing that, but I prefer a different way to select locations to place the line. So I'm just going to click Oops, and then keep doing that. Right click and choose Oops in the work area. Whenever you make a mistake, you can just right click and choose Oops, and it'll correct the mistake. All right, so what method do I use? I like to just type in the coordinates for when I'm selecting where to place the lines. So if you look in the command window here, whatever you type will show up. I'm going to type in X coordinate space Y coordinate space and then 0 space 0. What that means is the first 0 is for the X coordinate and the second 0 is for the Y coordinate. And once I hit enter, it gets selected. Notice how it clicks and chose exactly on the 0, 0. This is very useful when you want to make extremely precise selections. Alright, so you can also do just the X coordinate or just the Y coordinate. So I'm going to go with X space, and remember in the datasheet the width is 5.01, so I'm going to do that. I'm going to select 5.01 in the X coordinate, so hit enter and we've selected 5.01. Let's go down in the Y coordinate, so Y negative, let's see here, B is 6.65 in height, so we have to go negative 6.65. Negative 6.56. All right, enter. Okay, I'm going to zoom out, and then I'm going to choose the x coordinate. It's back at 0 again, so let's go to 0, x 0, and then lastly y 0. All right, that's the last position chosen. So right click the work area and choose done. Your shape is made, and now you're ready to copy the shape. Why would we copy it? Well, I'm actually going to copy it to put it on the package to create a package geometry assembly top layer for outline. So how do you copy? Go to edit and then choose copy. Click on the outline here that we just made, and then you can drag it around and then place it wherever you wish. I'm just going to click once and then place it there, and then right click and then choose done. Now both of these are the package geometry assembly bottom. I want to change this new copy to assembly top. Now you may get this problem where you can't click anything. That's fine. Just go to the general edit option and click general edit, and then it allows you to choose that. There are other ways to get out of that issue as well, but this is the easiest way. So click and highlight the entire line setup here, and then just right click, change to layer, assembly top. Same active class or subclass, just the subclass that we changed to is the assembly top and not the bottom. Now that that's done, you see the colors changed to assembly top color, and I'm just going to click on the move here in the top of the menu bar. If you don't have the move shortcut, you can just go to edit and then move. Now notice only the lines, the individual lines are highlighted when I hover over them. So what that means is I have to click, drag over the entire outline for assembly top, right? And then once it's highlighted, left click once, and don't drag, just do one click and then move it. Place it around the origin so that the origin is as close to the center as possible. I could use calculations and precise clicks and all that, but I don't want to do that because I think I can pretty much eyeball it. All right, and then just once you place that, that's fine. You're still in move mode, so what you do is just click once on the initial shape that we made for the package geometry assembly bottom, and then place it directly under or over, if you think of it that way, right where you place the package geometry assembly top outline. And click once to place it, and then right click and then choose done. Excellent. That's placed. Now we won't be able to save this as is. If you try to save it like I did just now, the software will complain. It says that its symbol is missing a reference designator, so it will not save it. So let's create a reference designator. To do that, you need to add some text. Click on the add text option, or if you want, you can just click add in the menu and then choose text. So where do we want to place this? Okay, the text needs to be in the active class of reference designator. So in the options, click on active class and subclass drop down menu, click on reference designator, click on then the, let's see, where's the option? Assembly top. And then now you're ready to place, before we place it, I want to use the size 2 text block, not size 1, because size 1 is a little small. So let's go with 2, click tab, and now we're ready to place the text. Just perform one click on the center of the package, and let's type in something like ref. Why am I choosing ref? That's because you'll see at the end of the video why I chose ref. Alright, so once that's typed in, just right click and then choose done. And I'm going to add some more text. I'm going to use the shortcut this time, add text. And this time I'll go with reference designator, but a different subclass, silkscreen top. Text block, it remembered that I like the two size text block, so Now we're ready to place the text. Just going to place it right here and type ref again here. And that's good. Choose done and we're good to go. Now the colors are the same for the reference designator. I don't like that. I like my silkscreen to be a different color. I would choose white. So how do I do that? Okay, in order to do that, let's see. Now I can almost never remember where to put the choose the color option here. So I'm just gonna see where I can find it. Okay. All right. Let's see. Okay, that took me a while to find the color option. All right, so it's actually just right in display, color and visibility. All right, so just click display, color, visibility, and I'm going to make the silk screen for all of the layers that I'm interested to be white. All right, so let's go click on geometry, package geometry, and the silk screen top I'm going to make white. In order to do that, scroll down, and where we see silk screen top here, it's set to green. I'm going to choose the white in the color palette and then click here in the silk screen top box to make it white. Click apply and that's white. Now next I'm going to go to components and then choose reference designator. This is what we're actually seeing here. The silk screen top here is blue, so I already have white selected in the lower left from earlier. So choose the blue box and silk screen top and click on it to turn it white as well. All the other colors I'm going to keep the same. And I will change something else but down the road. So click apply and then click OK. Notice that the text is white. What's the last thing we need to do here before we create the pad stacks? Well, I'm going to go to Setup tab in PCB Editor and then choose Design Parameters. In the Design Parameters, I'm going to choose the Text tab and then click Setup Text Sizes. Why am I doing this? Because the photo width of the text is actually set to 0. This can create problems when you're trying to, just warnings when you're trying to create artwork files for your part. So you want to make sure that you have something at least like a 0.1 millimeter line width. And I like to do that for all the text that I think I'm going to use. So I'm actually going to highlight this and then Control C for copy and then Control V to paste in these different fields. Okay, so that's enough of that. I'll click OK button and then click the apply button and then click OK. Notice that the text has gotten wider in width, and when we try to save now, it will set up a warning that says the file exists and do you want to overwrite it? I'll click yes. And now it's saved. And notice in the lower left that the PSM file of this footprint package or the symbol was created. That's when you know that it's saved correctly. Okay, now that that's done, we'll just leave this open and I'm going to go to Padstack Editor to create the custom pins. Let's go to Cadence Release 17.2 and I'm going to go with Padstack Editor. Click on that. Alright, so what kind of pad stacks are we going to make? Let's look at the data sheet. There will be 3 different sizes. This pad number 1, pad number 2, and pad 3. In the data sheet, they're also named A, B, and C. Okay. So I'll just go back into the Padstack editor here, and they're all rectangular. So I will go with a SMD pin, rectangle, and again, the units are in millimeters. So I'm going to change the units in the lower left to millimeter. Click yes if it talks about loss of accuracy. Alright, and we're good to go. Click on the Design Layers tab. With the Begin layer, that means the top copper layer, is the regular pad. Click on the field where it says none, and then on the lower area for the geometry field, click the drop down menu and then choose rectangle. Set the width to whatever the datasheet says. So let's go back to the datasheet. I'm going to go with this top pad since it's pad number 1, and its width is set to, let's see here, what is its width? Okay, excellent. We have the pad sizes already, have the measurements here from the engineer. So the engineer suggests 3.86 for the width and 0.70 millimeters for the height. So that's what I'm going to put in Padstack Editor. 3.86 for the width and 0.70 millimeters for the height. Next, go to the Mask Layers tab, and I always make this solid mask top layer a little larger than the Padstack. So choose Geometry, Rectangle, and I will make it 0.1 millimeters greater. So 3.96 and 0.80 millimeters. Now that that is set, there's also the solder mask top that you may want to consider. The paste mask top. It is for solder paste. You want this to be smaller than the pad stack, alright, or the pad pin. So what you want to set it to is something less than that. So I'm going to go with 3.66 millimeters in width and 0.60 millimeters. Click Save, and what it'll do is prompt you for a name of the pad stack. So just click inside the same folder as the packet symbol that you're working with. Why would you do that? Because, well, it's going to automatically add the pad pins or the pin pads, pad stacks that you're creating to the project for PCB Editor, so you don't have to do it manually. So that's good news about that. I'll use the nomenclature of pad underscore 386 for the millimeter dimensions by 070 in the height, and then underscore R to indicate that it's a rectangle. Click Save, and that is saved without any problems. Great. Next, we'll create pad number 2. Go to File, New, and then the pad stack name, well, let's first choose the type of pad stack, SMD pin, and I'm actually going to click on the Browse button, and then I'm going to name it pad underscore whatever these dimensions say in the datasheet. So for pad B or pad pin 2, the width is 0.70 millimeters and the height is 1.1 millimeters. Alright, so I'm just going to go to Padstack Editor and then go with 070 width, X, 110 height, underscore R for rectangle, and click Save. It's SMD pin for the Padstack usage. Make sure it's in the same directory as the complex footprints package you're working with, and then click OK. Alright, so we'll choose SMD pin rectangle. It's already selected. Millimeters. All the settings are the same. All we're doing is changing the design layer information. So click on the design layer tab and select pad to change. Begin layer. Choose the geometry field. Drop down menu, and then go to rectangle. Set the width to what the data sheet says. I already forgot what it said, so B is 0.70 in width, so set it to that. And then the height is 1.10 millimeters. Alright, so mask layer, as before, we'll go to the mask layer tab, click on the geometry field where it says none, click on the rectangle option, and make the width 0.1 millimeters greater than the width of the SMD pin. That would be 0.80 millimeters, and the height would be 1.2 millimeters. As for the paste mask top, do the converse. That is, make it a 0.1 millimeter less than the SMD pin. So 0.60 for the width, and let's see, 1.0 millimeters for the height. And let's see, did I do that correctly? Let's double check here. Alright. Okay, yeah, I think that's good. So click save, and the last thing we're going to do is create the third pad. So same process, go to File, New, click on the Browse button, name the pad, pad underscore. Let's see what the dimensions are for the last pad. It is, for pad C, 3.86 by 3.17. Okay. 386 by 317 underscore R. Click save. Padstack usage is SMD pin. Click OK. Everything's already set up for us again, so just go to design layers. In the begin layer, we'll choose the none field, and in the geometry field at the bottom, click the drop down, choose rectangle. The width of the SMD pin will be 3.86 and the height will be 3.17. The mask layers, we will choose solder mask top, and then geometry set as a rectangle. Width is 3.96 and the height will be 3.27. Lastly, the paste mask top will be less than that would be 3.66 in the width, and the height will be 3.07. Just save that, and those are the three pad stacks. Alright, so close Padstack Editor, and they should have been created in your folder. So just double click on the folder, and let's see. The extension for the pad stacks are .pad, and that's what you want to see in the extension, and they've been created correctly, so that's good. Let's go back to PCB Editor Lite and put these pad stacks inside the package symbol. Alright, so you can go to the shortcut. Usually there's a shortcut for add pin in the upper right portion of the screen. But if you don't have that, you can always go to layout and pins. Don't know why they put it on the layout, but that's fine. So now you want to choose the connect option in the options tab, and then for the pad stack you will click on the ellipses and then just type in pad underscore. Why? Because all of our pad stacks we give it pad underscore and place an asterisk at the end. So what this does is when you hit enter, it searches for the pads that have been made, and we will place the first pad stack. So pad 070, click on it once, and oh, actually that's not the first pad. We want to go with pad 386070. So then click OK, and we're going to place it. Now, where would you place this pad stack? Alright, or this pin, if you will. First of all, you want to make sure that the pin number is correct and that the text that's going to be displayed is also correct. So this is pin number 1 and text block 1, so that's fine. Where do we place this? Luckily, the datasheet has that information. So if you notice, from the center of the package geometry, you will place the pad some distance above the center of the package. So this distance is called small d, and it's a certain number of millimeters from the center of the package, 2.91 to be exact. So how do we place this? Go to PCB Editor, and we're going to use the exact placement method. I'm not sure what to call it, but it's we use the coordinates on the keyboard to place the pad. So the default location is 0, 0 in the center, the origin. So let's see, our x coordinate would be 0, and the y coordinate would be 2.91 millimeters. So let's type it in. X space y space 0 space 2.91. Enter. The pad stack has been placed. Let's go place a second pad stack. So click on the ellipses in the options tab. Type in pad underscore, hit enter, and the second pad stack will be the 0.70 millimeter by 1.1 millimeter. Click OK, and now it's selected and we can place it. Double check that the pin number is correct. Pin number is set to 2 and text block will make it 2. Click in the different field to make sure that field gets updated. Always do that. And now we're ready to place it. So let's go to the datasheet. It's pad B or pad 2. Let's see, H. we are an h distance below the origin and a g distance to the left of the origin. That means we're going to have negative coordinates from the origin. So negative g and negative h will be our coordinates. That means negative 2.13 and negative 1.81. All right. So type in x, y, negative 2.83 and negative 1.81. I think I got that coordinate correct. Let's see. Oh, 2.13, not 2.83. So you can always delete whatever you type. The cursor doesn't show, but it's always there waiting for your input from the keyboard. So negative 2.13 and negative 1.81. Hit enter and the pad has been placed. Now I'm just going to repeat this process with the last Padstack. Click on the options tab, Padstack, ellipses, pad underscore, hit enter. 386 and 317. This is the largest pad and the last one that we'll place. Let's check the coordinates. Go to the data sheet. It is E distance to the right and F distance below the origin. So E positive, or positive E and negative F. So positive 0.55 and negative 1.67. X, Y, positive 0.55 in the X direction and negative, wow, I already forgot. Okay, let's see here. Negative 1.67. All right. 0.67. And hit enter and the pad is placed. So right click and choose done and all of the pads have been placed exactly where they need to be. These text numbers kind of bother me because they're not right where the pad is. So if you ever have that situation, it would be a good idea to kind of place them wherever you want them, but I like to place them right in the middle of the pad. Now again, I am not able to click on anything. So what I'm going to do is right click. Oh, actually I can't even right click. So I'm going to go to General Edit, and this is the General Edit button. Now I'm not exactly sure where to find in the menu the General Edit option with this shortcut button here, but in case you don't have that, in the command window you can type General Edit and it will put you in General Edit mode. So that then you can right click and move around and do what you need to do. I'm going to show you another cool feature you can use, which is the Super Filter. So once you've right clicked on the work area, choose Super Filter. Now Super Filter is set to off. That means you can select anything. But let's say we only want to choose text. So right click, left click the text option, and now you can only select text. You can't select anything else. Now the pin numbers are in text, and their color, I don't like the color because it's green and it's difficult to see. So I'm just gonna click and drag. I can click and hold and drag the pin number to move it around. I'm gonna place it right in the center of the pad. Same with pin number 3 and same with pin number 1. How am I going to manipulate the color? Well, just like I did in the earlier part of this video, I will go to the color options right in the shortcut toolbar, or you can go to display color visibility. Now, where is the option to find the pin number? We saw it earlier. If you may have noticed it, it was actually in, I believe, geometry, package geometry, and pin number is set to green. So you want to choose a different color. I like to go with yellow, and I click on the yellow box and then choose the pin number box and click it to make it yellow. Click apply and then click OK. Notice that the pin numbers are yellow. So this is pretty much everything that we need for the package geometry, save for one last item, and that is the silk screen for the package outline. So I'm just going to add a silk screen for the package outline. How would I do that? Just go to add a line, and what active class would I use? So I'm going to go with the package geometry and just click on the subclass drop down menu and choose silk screen top, because this is the geometry of the package. The line lock is set to 90 just like we had it before, and the line width is 0.12. I like that line width, so I'm just going to zoom in and then click just to indicate the corners. Click on the corner and then click here and then right click and choose done. And whenever you click, you do not drag the mouse. You don't hold down the mouse button. You just do a click, release, and then move the mouse, and then make a click to terminate the connection. Alright, so I'm going to repeat this step with the silk screen corner, package, outline corner. So let's go to add, line, and I will repeat, place another corner on the upper right along here, right click and choose done, and let's go down. If you don't know how to pan, if you maybe your mouse has a middle button, hopefully it would because it's very convenient. You press down the middle button of your mouse and then drag down while holding down the button. That allows you to pan in PCB Editor. So if you don't have a mouse that has the third middle mouse button, you definitely, it saves time to get one. You can also navigate by hitting the up and down arrow keys. So that's another way to do that as well. Okay, so the last line I'm going to do is click add, line, silk screen top, everything is the same. Click here once, and then click release again, and then click release, and then right click, and then choose done. Okay, and then lastly, I have to do it one more time. Let's put it in the lower right corner here. Yes. Okay, not precise or perfect, but it's good enough. So let's just click save, and it's asking if we want to overwrite the existing footprint or the packet symbol. Yes. Alright, now the PSM was created again. Excellent. You've just finished creating a packet symbol from scratch for an arbitrary, really awkward and unusual footprint here, with everything that you need to go and continue your design. Now, luckily, and I don't see this too often, if you click on the company's website with the page, you would have noticed that it has a PCB design library, a thermal model, PSpice libraries, and LTSpice libraries. So that's really good. They've definitely put a lot of information in this package here. What I can do is click on this, and I can download the PCB design libraries. If you ever run into this situation, definitely do that. Why is that? Because you'll be able to download what they've already made, and these are just the footprints. I have another folder here that you would have noticed. Double click on this, and this has the packet symbols already. So I unzipped the folders and then looked at the footprint release. These drawing files, these .dra files, do not have a program associated with it. I would use PCB Editor to open it. So let's see, let's open this GS66504B. So let's go to PCB Editor, File, Open. Let's go a folder up, go into this folder. Let's see here. Make sure that you're looking for symbol drawings, the DRA extension. Alright, now they've already made a packet symbol. So let's see how it looks. GS66504B. Click open. It was made in a previous version, version prior to 17.2, so we're going to upgrade it when opening it. So click yes, and look at that. It's pretty much the same. Now, they do have different colors for the silk screen top, and also the pin number has, I bet this is a 0 line width pin number. And how do I know that? Well, I can just tell from looking at it. But what you can do is right click the work area, super filter, and then click text. Now I'm able to select the text. Now I want to know more information about this text. Alright, so while it's highlighted, I'm going to choose the show element I button. It's a little I in the shortcut toolbar here. Click on that, and it gives you information about what you have selected. So 0 rotation and everything, text block 1, and let's see. Okay, so text block 1 is the type, but that doesn't tell me what the line width is for this text. So just click close, and I'm going to go to their setup, design parameters, and let's look at text, setup text sizes, and yes, sure enough, the photo width for text size 1 is 0. If we change it to 0.1 millimeters, it will change the width of the text. So click apply and then click OK, and look at that, it's been changed. Alright, yeah, I just wanted to show you guys that, and luckily this package symbol is already made by the engineers, but you were able to do many things in this video. You learned how to create the silk screen for package geometry and indicate that. You also learned how to use Padstack editor to create pad stacks, customized pad stacks. So basically you can make any pad stack you want and place it any position you'd like. You learn how to do precise precision placement, precision, or whatever you want to name it, in PCB Editor. You also learn how to add reference designators, which are mandatory components of any package symbol in OrCAD PCB Editor. And you learn how to organize your files and create a package symbol that can be used in OrCAD Capture. Thank you for watching this video. I know it was very long and there's a lot of information here. So really appreciate you watching this video, and I hope it serves you well and allows you to create any footprint that you want. Please definitely look at my other videos and tutorials right on YouTube, and I'll give you any information you can use to apply your knowledge in PCB design. Thank you.